Okay, catalysts, aluminium and iodine. Aluminium and iodine will react, but I'm going to need a bit of help with it. I'll show you. Sometimes things react just by contact. These two is less of a case. So here is our iodine, here is our aluminium. Okay, now if I just add them to each other, nothing's happened. Okay, now I could put in a lot of energy and actually start to, if I start mixing them as vigorously as possible, I might get them to react, but it is unlikely. I want to ground my iodine up, but it's decided to reform a big block of it. One second. Now, iodine is what's used, or used to be used as a disinfectant. So a lot of old people, if you've got a cut or a scrape, would like to try to put iodine on you to disinfect the area. And as you can see, it's marked the desk a little bit. You might not be able to see it on camera. Okay, but I'm mixing them. Still no reaction. Mixed them quite well. All the atoms of each other can touch each other, but nothing's happening. What I'm going to need is a catalyst. And I'm actually going to need to take it to the fume cupboard because this reaction, as you'll see, creates a lot of gas, and the gas is not a great gas to be inhaling. So you can see there's where some of the iodine has escaped onto the desk. So let's take this over to the fume cupboard and see if we can get a reaction. Now, what I'm going to do is place it on this tin lid here. And I'm just going to make a tiny little crater at the top. And then we're going to add our catalyst to this. Poor old iPad, you're going to have to stay inside the fume cupboard. I trust you. I think you'll be fine. So, the catalyst that we're using today is just warm water from the tap. That's all it is. Now, those two currently in the metal tin lid there might react on their own after a couple of hours, but this catalyst is going to speed it up remarkably. So I'm going to put, in case the catalyst or water in it. Now remember, catalyst can be reused, and if we were to evaporate the product afterwards, we could get our catalyst back as water. Okay, so let's turn the fan on now. So it's a little bit loud, as you're about to see. One. Right, it must be said that there's a bit of a lag in this reaction. So it doesn't start straight away. Might add some more. Oh no, we're off. There we go. And we're off. So, aluminium and iodine. We know a chemical reaction is happening because all that gas has just been produced. What do you think the product might be of those two? It is aluminium iodide. Remember, the metal goes before the non-metal. The purple gas you saw off was excess iodine vapour that didn't get used up in the reaction. So that's why that went to that colour. But there you go. That is an example of a reaction that needed a catalyst to get it going, and actually has quite a vigorous reaction when the catalyst is present. The other benefit of the catalyst is it actually causes all of it to react, or as much of it as possible to react. compared to those two on their own might react, but it may not get every atom reacting. Okay, so that's one example. Another example, we're going to look at, as I mentioned in the video, slightly too far away, hydrogen peroxide. Hydrogen peroxide, chemical formula not on here, is H2O2. Remember that it's not a very stable compound, that oxygen is the extra oxygen is constantly trying to break away. And we keep it in the fridge, keep it cool. But when it gets up to room temperature, it will start to lose that extra oxygen. But it is very slow. We're not going to see it happening. It's going to take too long. We left that overnight, that probably would just turn into just general water and oxygen, but that's going to take too long. We're going to use our catalyst. Now, for hydrogen peroxide, there's lots of catalysts. We're going to use manganese oxide. Okay. This is going to work quite well in this case, as you will see. So, currently, no reaction happening really at all that we can discernibly see. It will be happening very slowly. Let's speed it up with a catalyst. Try not to chuck it all over the desk. Now we're creating water and pure oxygen. And again, if we evaporate all that water, we can recover our manganese oxide. Don't mind our student back there who forgot the message about lockdown. Right, there you go, two examples of catalysts that you lot can use as examples in a minute.